Number 1, find the critical points for each of the following curve. Given this curve, polynomial, and set. To find the critical points, okay, first thing is we need to find the first derivative. Okay, dy dx or f prime of x or dy dx, and check. So for critical point, f prime of x, okay, when f prime of x is equal to 0, this one called critical point, and also critical point, and also stationary point. Then, okay, f prime of x, okay, is undefined. Okay, this one is considered critical point, only critical point. So differentiate y with respect to x, f prime of x, and find when f prime of x is equal to 0 and when f prime of x is not defined. Okay, discuss A, B, C. So number 1A, this was simple, x squared cube, okay, minus 27x. So now critical point. Kalau point sebut points ya, mesti ada partner lah xy, point xy. So critical point ni ada dua cara nak cari. Okay, first is whatever it is, differentiate dulu. Okay, differentiate dulu f prime of x. Differentiate. Okay, but make sure fungsinya ni fx ni define, is define. Dia akan bagi yang define lah, kita tak payah fikir. So find the critical point. First sekali we need to differentiate dia, whatever differentiate dia. Kita do all for this chapter, differentiate dia kerja. Kita tak fikir lebih. And then when f prime of x is equal to 0, okay, and f prime of x is not defined. Okay, so ada two cases of critical point. Okay, this is critical point. Two cases. First is when f prime of x is equal to 0. Okay, this one called, ini case ini critical point and stationary point. Okay, untuknya point. Okay, this one. But when this one only f prime is not defined, ni kita panggil only critical point. Ke point je. Okay, satu je. So now first thing kena differentiate. So we differentiate this one. Differentiate simple. Actually simple point, dia bagi you all simple function. Not too tough lah. Ini 3x squared minus 27. Okay, normally this is polynomial function. Polynomial biasa normally consist of stationary je. Yang f prime of x not defined tak ada. Biasanya f prime of x not defined tu bila given yang differentiate, okay, dia produce ratio. Okay, denominator nak equal to 0. Itulah. Itu okay, kita concentrate on part A yang ni, this number first. And then when dy dx is equal to 0. Ni macam you all punya kena setkan lah. Okay, always is equal to 0. Okay, to find the extremum, minimum or maximum, dy dx is equal to 0. Okay, so take this one is equal to 0. Okay, so it implies that 3x squared minus 27 is equal to 0. Is equal to 0, and then factorize. Okay, then quadratic. X plus 3 is equal to 0, then x is equal to 3, or x is equal to negative 3. So because of this critical point, you need to find partner y. Jangan tinggal is equal to x and negative 3. No, this is not that one. You kena cari partner dia. Okay, when x is equal to negative 3, what happened to y? And when x is equal to 3. Substitute lah. Substitute y into y is equal to negative 3 cube minus 27 negative 3. Okay, this find for me. This is negative 27, right? This is 81 ke? Carikan. 81 minus 27 dapat apa? Carikan. Apa? 54 ke apa? Betul ke ni? Hitam je. You. Nyak je.
Betul.
Okay. So y is equal to 3 cube minus 27. 0 tak apa. 27 minus 81. Ini plus minus confirm negative 54, right? So, jangan tinggal macam ni because of point. Point ni tak kena. Therefore, negative 3, 54 and 3 negative 54 are critical point. Okay, so habis. Okay, say dia kata determine maximum minimum kan. So just find critical points. That's all, that's it. So the answer is this one. Okay, settle. Okay, before that critical points. Okay, when fx is defined, confirm fx defined. Okay, and then you need to find f prime of x, differentiate function. Fx define. Okay, define and find the first derivative f prime of x, and then we check. Okay, maybe this one. Okay, f prime of x is equal to 0, called stationary point, and f prime of x is not defined. Okay, so now for critical point, okay, first thing differentiate. When differentiate, okay, so the result f prime of x is equal to 0 to show this is stationary point, okay, and also critical point. Critical point lah kan? Dia punya critical point. Okay, and when this one, okay, f prime of x is not defined, normally after differentiate you get in ratio numerator over denominator. Denominator is equal to 0. When denominator is equal to 0, f prime of x is not defined. Okay, this is actually we call only critical point. Okay, yang the special we need to concentrate on this one. Normally this one lah, stationary point and also critical point. You still need to know this one because all this one stay in your syllabus saja. This one lah kan. Okay, so whatever it is, okay, for this part, okay, you have to differentiate and it's equal to 0. That's all for this part lah, for extremum, the extremum problem. Okay, so given number 1b, okay, fx is equal to x minus 1 square. Okay, either you expand or use product rule. So which one you want? Nak expand dulu or nak use product rule? Which one? Nak apa? Tak dengar. Product rule. Expand product rule. Okay. So this is u v. Okay. U prime du dv v prime. Okay. And u is x minus 1 square. Okay. And 1 2x minus 1 and differentiate x minus 1 1 lah, and dapat 2x minus 1. Set up. Then using the product rule, y is equal to uv y prime u prime v plus u v prime. Okay, take this one ni kan. this one. So find the f prime of x. Okay, so to up plus, okay, here. So 1, okay, x minus 1 b plus x v prime. Okay, and okay, maybe you need to expand lah. Expand. Okay, expand x squared minus 2x plus 1. Yang this one is 2x kan? Okay, 2x times x times negative 1. Jadi plus 2x squared minus 2x. Can we simplify? 3x squared minus 4x plus 1. Okay, that one is f prime of x. Then when critical point means that find when this one is equal to 0. Okay, f prime of x is equal to 0. Here is equal to 0. That implies that, okay, 3x squared minus minus 4x plus 1 is equal to 0. So this one is equal to 0, is equal to 0. Why? Because of you want to find critical point and at the same time this is stationary point. This is stationary point lah. So it's 0. Okay, this one not involve this part, the critical point only because of the f prime of x polynomial, produce polynomial. So maknanya no denominator lah kan. Okay, so all function, all f prime ni, this function define lah kan. Tak ada is not defined. So tak ada, this part tak ada lah. Okay, for this question. Okay, and then okay, factorize. Okay, factorize kan, ni negative 1, negative 4. Okay, x is equal to 1 over 3 or x is equal to 1. Two values for x. Okay, say that the question asks you to find critical points, means that you need to find y for the next one. So okay, when x is equal to 1 over 3, when x is equal to 1, find y. Tak benar kan? So ini dia f of 1 over 3. Okay, substitute lah 1 over 3 ni function use this function ni. Okay, substitute. Okay, 1 over 3 minus 1 square. Okay, and then 1 over 3, 2 over 3, right? Negative 2 over 3, 4 over 29 dulu. Okay, 9 dulu. Dan baru 4 over 27. Okay, dan this one f of 1 minus 1 0 lah. Okay, is equal to 0. And this point 1 over 3, it implies that therefore, okay, point 1 over 3, 4 over 27 and 1 0 x y, okay, x y, okay, are critical, mana pula ni, critical point. Okay, so settle. Tak payah nak test maksimum ke minimum ke, dia tanya critical point. Situ settle lah. That one is for introduction for critical point. Critical points, first thing, whatever it is, you need to differentiate, find f prime of x. Okay, and check. Okay, then that one is consists of ratio denominator not equal to 0 lah kan. Okay, 1c. Okay, for f of x times x plus 3. Okay, so now introduction for critical value. Okay, critical points. Okay, so first thing, for critical points given to you is f of x is defined. Okay, this is not your problem, kan? F of x is defined. Okay, and what should you do is differentiate. Find f prime of x. Differentiate. Okay, differentiate. Then this one you have to consider. Okay, this one you have to consider when f of x, f prime of x is equal to 0 and f prime of x is not defined. Okay, so this one, yang ini, critical point ini, okay, this is called all critical point. First, differentiate first. Okay, let's say when f prime of x is equal to 0, this one consider stationary point. Okay, and this one actually stationary point and critical point lah. This is ada critical point right saja. Critical point. Okay, nak highlight lagi. This is stationary point. Okay, the value of x is stationary point and critical point. So for f prime of x is not defined. Normally after first derivative, you get the ratio. Check the f prime is not defined. The denominator is equal to 0. When not defined, the denominator is equal to 0. So this one consider critical point only. Of course, this one critical point kan? Ni. Your title is critical point. Okay, so this is critical point. So make sure for critical points you have two things lah. Kalau let's say f prime of x, find f prime of x first, then check when f prime of x is equal to 0, that is called critical point and stationary point. And when f prime of x is not defined, this one consider only critical point. And then try this one, 1c. Okay, differentiate 1c. Okay, we write. Okay, what rule should we apply? Apa rule? Rule apa?
Product rule.
Product rule. Okay, and then u is equal to x. V is equal to set x plus 3. U prime or du dx is equal to 1. V prime or dv dx is equal to 1 over 2 set x plus 3. Differentiate x plus 3 is equal to 1, right? 1. So this one, or you can change this one to x plus 3 power of half and differentiate. Okay, and now using the product rule, okay, f prime of x is equal to, okay, up, okay, plus down, right? And then 1 times set x plus 3 plus x times x, 1 over 2 set x plus 3. Okay, equate the denominator. Okay, simplify, up, take all, or just take the square root, x plus 3, bring up, plus x over 2x plus 3. Okay, simplify. 3x plus 6 over 2x plus 3. And then there is f prime of x. This one in this form, this stage. The f prime of x is at this stage. Okay. And now we need to determine, because of the question ask you to find critical points, and so maybe decide that what that point is critical and stationary or only critical point. Okay. Actually that one is actually under critical je. Okay. Stationary hold dulu. Kita nak test ni je. And for this question test ni je. Ni je critical point je. Okay. Then, okay, first nak test f prime of x is equal to 0. Okay, the first step. Okay, the first case, right? Okay, second is when f prime of x is not defined. Okay, so you have to check two cases lah. Okay, and this one is fx, f prime of x. So for f prime of x, take this one, 3x plus 6 over 2 third x plus 3 is equal to 0. Or 3x plus 6 is equal to 0. Therefore, x is equal to negative 2. Okay, this value, critical value. Okay, for this part, f prime of x is not defined. Okay, check. Ni, check. Okay, when f prime of x is not defined. Okay, so f prime of x is not defined when apa? Denominator, numerator is equal to infinity ke 0 tadi. Okay, numerator something over 0 or okay, something over infinity or 0 over something or infinity over something. So which one consider, which one can produce f prime of x is not defined? Mana case? Which one? Ni ke? First, second, third, fourth? Which one? What happened for this one, this function, when this function is not defined? So, suppose numerator ke denominator ada problem. That's bad. That's respond. Cepat. Which one? Numerator
Yang bawah problem.
Yang bawah, okay, good. Yang bawah problem. So, cancel yang atas. Yang bawah problem. So, yang bawah tu ada problem apa? Which one? 0, infinity. Yang ini, cancel lah. Tak ada apa. Okay, 0 ke infinity? Cepat. Terus. Okay. When this one is equal to something, is it equal to infinity or is equal to 0? So, that f prime of x is not defined. Cepat. Ada problem apa ni? Jadi ni, case ni. So, let's say 3 over 0. Yang ni consider apa? This one, 3 over infinity is equal to apa? 3 over infinity. 3 over infinity is equal to 3 RM3 ringgit. Okay, divide to 1,000 people. So, this one is almost what?
Almost 0.
So, this one 3 over 0 is equal to infinity, right? Undefined. Okay. So, okay, this one is equal to 0. Ya, ini is equal to 0. When this one denominator is equal to 0, this function f prime of x is not defined. Okay. Let's say kalau it's not equal to 0 slash not equal to 0, convert this function is defined. The opposite, right? Okay. So, find x plus 3 is equal to 0. Therefore, x is equal to negative 3. Okay. Okay, so value of x done. Okay. Now, actually, okay, this is one method to remember. This is not very good for concept, but for you. Okay, here, check here. You find the f prime of x, first derivative. When get ratio, yang this one this one is for f prime of x is equal to 0. Okay, this is the way to remember. This is actually not very good concept. Take this one is equal to 0. Okay, for critical point and stationary point. Okay, and then this one denominator. Okay, means that this function is not defined. Okay, take this one. It's not defined. So, up numerator is equal to 0 to show that this one critical and stationary numerator. Denominator is equal to 0 to show f prime of x is not defined. Senang. This is the way to remember. Okay. And now we need to find y. Okay. So, substitute f of negative 2 and negative 2, 3 negative 2, 1, and is equal to negative 2. Okay, f of negative 3, negative 3, 0 lah, kan? So this is equal to 0. So now we can conclude, okay, therefore, negative 2, 2, and negative 3, 0 are the critical point. The critical point. Okay, this one, x value, y value. Okay, so point. Okay, x value, y value, point. Okay, so yang this one special case. Okay, and okay, all this point, all critical points. But for this one special, stationary point and critical point. This one only critical. Okay, settle lah. So settle for number 1. Easy. Okay, settle. Okay, any problem? So dapat rough idea kan? Dapat rough idea sikit pasal critical points. Okay, tengok ni cik kan? Ni critical points. So have two things you need to consider when f prime of x is equal to 0, or numerator is equal to 0, and denominator is equal to 0 means that f prime of x is not defined. Okay, first thing you need to differentiate, find f prime of x. First thing in this chapter, in this 10.1, differentiate je first thing. Number 2, use the first derivative test to determine the relative extrema points. So the first derivative test is dy dx. Okay, and relative extremum point, extremum refer to maximum or minimum. Okay, so relative refer to at that area or local extremum, relative extremum. So first thing, find differentiate y respect to x. Okay, and find the when dy dx is equal to 0, find value of x, and using the first derivative s dy dx, okay, check whether the interval is, the graph is, or the gradient is increase or decrease, and from that one you can determine the type of point, whether maximum or minimum. Okay, discuss A and B. Okay, so to A, okay, function is y is equal to, okay, polynomial. Okay, so relative extremum. Okay, let's say the graph, this is the graph x, y, 0. Okay, the graph is something like this lah. Okay, first attempt. Nanti sikit curve lah, curve. Tak, dia tak sharp macam tu. Dia confuse. Okay, so now, okay, from here, determine the extremum. Extremum may be maximum or minimum. So from this graph, actually we cannot determine the exact value for minimum. Or actually the graph, okay, doesn't have minimum because of that one is from below the negative, from negative infinity we cannot decide the exact value for minimum. Okay, or we can say that the minimum is undefined actually. It exists but undefined. Okay, so same like as maximum also we can get the exact value for maximum because of it goes to infinity. Okay, so what we can do is check this region, this area and this area. Okay, so in this area the maximum value sini, maximum ni, this one in this region je, this is maximum. So we call relative maximum or local maximum. Okay, local area, this area, within this area, this point, the top one, the highest one. Okay, maximum. Okay, and here within this area, this is the lowest point or minimum. Called local or relative minimum. Okay, so now we can, let's say before you answer, you have to add on relative and local, maximum or minimum, because let's say during that area, the region, this one only the minimum, but we don't the exact minimum for this graph, okay, or maximum. So now we're going to find extreme point, minimum or maximum by the first, using the first derivative, right? Okay, differentiate. Okay. Okay. And then maximum, minimum. Maximum, minimum means that dy dx is equal to 0. Okay, so always to find minimum, maximum, dy dx is equal to 0. So 0. And 3x squared minus 12 is equal to 0. Okay, 4 is equal to 0. Quadratic, can bring 4 to the right and find plus minus, right? But this is quadratic, just want to show factorize lah. Kan? Okay, up to you lah. Okay, so x is equal to 2 or x equals negative 2. Two values for x ketika values. Okay, so we need to check, nak test using the first derivative. Okay, because of two values, you can check separately one by one, or nak save time. Okay, so using the number line, okay, we check. Okay, within the number line senang. Okay, so this is 2, negative 2, this is infinity, positive, negative infinity. Okay, okay, table lah, table. Okay, table. And check, this is dy dx. You want to check the gradient. Is it gradient increase, positive or negative? And is it the gradient is positive or negative? And the graph, increasing or decreasing? Okay, so now let's say mana dy dx. Your dy dx is 3. Take this one, take this, or take this one. Okay, so okay. So dy dx is actually 3x squared minus 12, or but you kena consider lah ni, kena consider, tak boleh get rid of 3 because this is expression. Kan ambil ni, kena get rid of 3 pula. Okay, kena consider all. Okay, and then from here we try to find the value of slope gradient, m. Okay, choose one number. Let's say actually take the near of ni, kat sini je. Okay, ni aja. Most this one is kali ni let's say this one negative 3, yang ni 1. Okay, consider 0. So choose the number is negative 2.01 lah. Because sometimes let's say the graph dia tukar pattern dia. If you choose negative 4 ke negative 5 maybe dah problem dah. Maybe the graph is dia change the behavior dia punya ni kan. Okay, so actually better choose the nearest number lah. Okay, let's say the neighborhood of negative 2 kan. So ambil negative 2.01 ke atau negative 0.5 lah kan, paling tu. Okay, so substitute sini or sini. So this one is negative lah. Negative. So ini negative 2.1. Kalau kita plus ni, so negative kan. Okay, so negative times negative, this slope is positive, positive. And then take this one pula, yang ini let's ambil ni lah, sebelah sini 1.99 ke 1.5 ke. Okay, let's ambil 1.99 lah, simple right, positive. Substitute kat sini kan, ni 1.99 less than 2, negative lagi. 1.99 positif plus positif. So negative times positif, negative. Kita check dia punya slope dia ada negatif positif je. So the last is kita consider ni je ni. Point negative 2 ni je kan, consider. Dia lebih pula kan. Take this one ni 2.1. Substitute dalam ni 2.1 minus 2 positif. 2.1 positif positif times positif lah. Settle. Then the graph graph, okay, gradient slope positive, the graph is goes up lah, increase. Ni negative, okay, decrease, increase. So now let's say in this one kat sini, okay, maximum. This is maximum. This is minimum. So maximum at x is equal to maximum. Okay, minimum at x itu negatif itu positif. Okay, so di sini when x is equal to negative 2, x is equal to settle, right? So now let's say okay, extra knowledge. Oh no, okay, here is actually the extra knowledge lah. This is for negative infinity to negative 2. Ni kita consider ni je, right? Okay, okay, and negative 2 ni to infinity. So this one let's say within the interval negative infinity to negative 2, this interval is increase, increasing interval ni. Kawasan ni this one is increase. Dia tulis dulu. Ni increase juga. 2 to infinity, increasing interval. This one is decrease, decreasing interval. So yang ini increase interval, increasing interval, and this one is decreasing interval. Okay, ada extra. Okay, and find the extreme point. So here, therefore, and partner lah, find the x, y, right? When x is equal to negative 2, when x is equal to, find y. Okay, y. Y is equal to negative 2 cube minus 12 negative 2. And then this one is negative 8 plus 24 is equal to 16. Okay, therefore 1. And y is equal to 2 cube minus 12 to substitute 24 because negative 16. Okay, therefore conclusion, therefore point negative 2 16 is a sini kan relative maximum. Okay, and then 2 to negative 16 is a this one kan ni relative minimum. Okay, so make sure this is a first derivative. So this one, all this one actually we call this one first derivative. First derivative. Then using the first derivative, the first derivative. Okay, and then using the first derivative to determine the type of the point, either maximum or minimum. Kan? Settle number 2 b. Okay, y is equal to 2x cube plus 3x squared. So now use the first derivative. Means that differentiate with respect to x. Okay, 6x squared plus 6x. And then extremum terus lah. Okay, whatever apa for in this chapter, terus dy dx is equal to 0, maximum or minimum. Okay, so implies that 6x squared plus 6x is equal to 0. Factorize x plus 1 is equal to 0, x equals 0, or x is equal to negative 1. Okay, and okay, you tahu because let's say two value, this is critical value lah. At this critical, maybe the graph, we don't know the graph is maximum or minimum. Okay, and then let's say if you sketch the graph, sketch graph. Okay, sketch graph. Okay, the graph is something like this, something right kan. So now, okay, for this graph, the exact minimum ni cannot be defined lah. From bottom now ni, negative infinity, we cannot find the exact, cannot determine the exact value for minimum. Same like maximum. Okay, the jump to up, right? We cannot find the exact value for maximum. But here, sini, around here, okay, here is the highest, okay, or this one is the highest one. This is maximum at this area. We call local maximum or relative maximum. Here also, this one is, the point is this one, the lowest, okay, the lowest one, minimum, okay, during this area, this region here. So we call local minimum or relative minimum. Okay, so now, but the real minimum for the graph is not defined. The real maximum for the graph is not defined. Okay, so from the two values, critical values for this one, okay, we need to define which one, negative, maximum or minimum, because of that one je, point of inflection is not in the syllabus. Okay, and from here kita construct a number line and table lah, senang number line table. This one is negative 1, 0, infinity positive, infinity negative. Okay, so you can do test this one by one, do the separate table, tak payahlah buang masa, right? Okay, and then table, okay, bagi sini, okay, table simple punya, okay, this one is dy dx, dy dx. This is pattern of the graph, okay, the increase or decrease, and here is interval, okay, for you, from negative infinity, 1, 0, 0 to positive infinity. So dy dx, okay, this one dy dx, okay, you take this one or this or this, take this one lah, okay, senang nak handle lah. 6x plus 1. Okay, yang di sebelah ni kan, dia punya ni dy dx. Okay, and okay, so now from the table ni choose one value. Let's say kat sini value, okay, sini value, if not sure, negative 1, this one negative 2, ni 0, 1, right? Ni between negative 1, negative 2, choose let's say negative 1.5 lah, okay, 0.5 ke 5 ke, sebelah je, substitute negative ni substitute negative, confirm it's negative lah, negative 1.5 plus 1 negative, so negative positive, you want the value either positive negative je, okay, and try this one pula ni, choose this one negative juga, 0.5, between 0 and negative 1, right? And let's say substitute in negative 0.5 negative, right? And 0.5 negative 0.5 plus 1 positive, so positive, negative lah ni, negative, okay. Ini this one choose kat sini choose 1, substitute 1 kat sini, 1 positive, 1 plus 1 also positive. So the interval increase or decrease, check lah, this one is positive, so interval dia kat sini up, okay, ni down, ini up, okay. So we need to consider this at this point, at x is equal to 0, at x equals negative 1. So ini dia punya ni at this point ni, this one consider maximum when x is equal to negative 1, kan. Ini minimum when x is equal to 0. So when talking about, let's say in interval, this syllabus code lah kan, you need to know, right? So interval, this one increase, this interval increase lah, increasing interval, okay. So increase, okay, increase, so this one is decrease, decreasing interval. So ini decrease, yang ni decrease. Itu yang ni. Ni from -1 0 decrease. Okay, and from negative infinity to 1 increase. 0 to positive infinity increase. Kalau tahu this one is extra lah. No longer yang syllabus but extra. Sampai dah tiba soalan extra sikit kan. So ini then here find the partner y ordinate. Okay, and substitute. Okay, when x is equal to -1. Okay, y okay, in y, not y prime, to -1 cube plus 3 -1 square. Okay, and then -2 plus 3 is equal to 1. When x is equal to 0, 0 plus 0, 0 lah kan? 0. So ini -1, 1, 0, 0. This one is maximum, minimum, and make a conclusion. This is using the table. The table ini shows that this is first derivative. And this table ni benda ni show the first derivative. Table ni, yang benda table benda ni show using first derivative. Okay, okay, and then conclusion. Okay, therefore, okay, -1 is a relative maximum. Mana betul? Confirm. Okay, and then 0, 0 is a relative minimum. Relative or local? Local or local. Okay, so that's for number 2. Number 3, find the coordinate of stationary points of this curve. So coordinate x, y. Stationary point means differentiate this function y with respect to x. dy dx. Okay, find dy dx is equal to 0 to take the value x. Okay, and from this value, okay, test whether this at this value point means that partner x, y, right? Okay, check whether the point is minimum or maximum. So to test this value, whether maximum or minimum, we can use first derivative test, or second derivative test. Okay, so try to discuss both. Okay, y equals x squared minus 54 over x, or simplify. Okay, bring it up. And then stationary point means need to differentiate and is equal to 0. Kerja for this chapter, differentiate and is equal to 0. So dy dx to x plus 54 x power, right? And then is equal to 0. Okay, and then 2x plus 54 x power, this one is equal to 0. Is equal to 0 to show this is stationary point. Okay, and simplify. Okay, bring to okay lah, negative 54 x squared, bring up x cube negative 27, negative 27, and this one, okay, cube negative 3, cube, therefore x is equal to negative 3, negative 3, and check whether this one is maximum or minimum. Okay, this one, let's say if you can use this, to discuss both first derivative and second derivative. Okay, and let's say you want to test whether the one is maybe, okay, to test maybe maximum or minimum. Tak sure. Using first using test, we discuss all. Okay. First derivative. Okay, first derivative. Second is second derivative. Very easy kan? Derivative. Okay, this one. Okay, and for the first derivative, okay, let's say you change to number line. This one consists of one je value for x. If two values just tak. Okay, positive infinity, negative infinity. Okay, and okay, let's say if two value, buatlah okay, table lah, column. Okay, and okay, so this is dy dx. Okay, dy dx. Okay, and this is the pattern of the graph, the interval, increase or decrease. So here, this one is negative infinity, negative 3 to positive infinity. Okay, and take one number kat sini, and sini. Okay, so sini senang, let's say 0 lah. Actually better, it's okay lah 0. Yang ini negative 4 ke negative 3.1. Okay, 4 lah. Okay, because of tu je kan. And substitute dy dx. Mana dia dy dx? Dy dx lah ni. Okay, take this one. Okay, okay, 2a 2x. Okay, dy dx kat sini dy dx 2x plus 54 x power apa? Ni check. Oh, yeah. Okay, so take this one, negative 4. Okay, yang ini take negative 4, substitute negative 4, negative lah, negative. Okay, feeling sad. Tak apa, redah je. And then this one negative 8. Okay, negative 8. And this one confirm positive ni. Ini over square kan? Confirm positif. Kita check juga dia nak good lah soalan ni. Pilihan tak good. Okay. And then 54 over 8. Berapa? Cuba cari value. 54 over 8 berapa? It's okay lah. I think this is negative Okay, check macam negative. And because of 54 over 8 is it less than 8? Kan? This one negative Check check for me. And this one macam ni 0. Substitute 0 tak sesuai. Okay, reverse. Tapi kat sana 0 kan? That's why lah, ambil yang near to this point. That is negative 2.9 kan? Bagus. Okay, because ada reflection. Okay, ni negative. Is it something like negative lah value? Cuba check. Ni 54 over negative 3. Cuba check for me. Saya nak detect je mana problem tu ada. Soalan macam okay. Check for me. Cepat. Negative 2 over 9 squared. 54 over negative 2 over 9. Cepat. Tunggu ni. And then minus ni. Dapat apa? Tak ada siapa check ke? Tidur lah kita sini. Check. Is it negative juga ke? Positif. Positif. Okay. I trust you. Positif. So, okay, tengok ni. Dia punya ini negative, right? Dia punya ni decrease. Interval decrease. Yang ini positive increase. Okay. So, this point, sini consider minimum. at this point, at this value, x is equal to -3. Okay, actually this one is minimum here. Okay, so kalau let's say consider for interval, this interval, okay, yang ni, this interval, yang ni decreasing interval ni, negative infinity to -3. If this one, this interval, this ni, dia punya gradient is increasing interval. Okay, keluar. Okay, so ni minimum lah. Okay, therefore ni minimum but you need to have partner lah. Cari when x is equal to -3, y is equal to -3 squared minus 54 over -3. Cari. Okay, pantas. Okay, ini saya tunggu. Cepat. 9 plus, okay, ni apa? 9 plus 18 apa? Is it 27? Macam macam ni, check kan? Check. Betul, salah. Ni nak buat apa ni? Ni soalan saya satu. Okay, saya guna mata dia kira. Salah tak apalah, sama salah. Okay, settle So, conclusion. Therefore, -3, 27 is a relative minimum. Okay, bisa minimum kan? Minimum. Relative minimum. Relative because of local minimum. Let's say the graph, along the graph, we know that what is under lagi ke, minimum ke, something right kan? So, but for this area, okay, that one is local. That part is the minimum kat situ lah. Kan? Settle. Okay, let's say using the second derivative. Okay. This one using the first derivative. The second derivative, dy dx is equal to 2x plus 54x. Right. And find the second derivative. Okay. To negative, ini apa? 108 kot x minus 3. Okay, and the settle. Okay. And substitute. X is equal to apa? -3. Ni lah. Substitute this one. -3 ni, yang ni. Yang this value ni. Ni. Substitute. Sini. Okay. And check. Substitute 2 minus 108 over -3 cube. Cari 108 over 27. Tunggu. Is it 82? 86 6. Oh, positif. 6 lah. Betul 6. Okay. Ini more than 0. More than 0. To show that this is minimum. Okay, minimum. So, when d2y dx squared, kalau ni more than 0, minimum. If less than 0, maximum. And, okay. So, point this one, right? Therefore, it's a minimum lah. Sama. Okay, sama. Dia punya conclusion sama. Sama. So, this one using the second derivative. Yang ni, this one using the first derivative. So, both lah. Make sure kalau let's say d2y dx squared dapat less than 0. This is maximum. Okay, more than 0, minimum. Okay. d2y dx squared more than 0, minimum. Relative. Settle for number Number 3. Number 4. Given this point, -1, 5 is a stationary point on the curve. Okay, in variable x and unknowns a and b. So stationary point, it means when differentiate y with respect to x, dy dx is equal to 0. Differentiate this one is equal to 0. Then substitute, okay, this value. Okay, x is equal to -1, y is equal to 5, and then okay, substitute this value and get one equation. Okay, and to find another equation, okay, just substitute this point to this function, and this one is first equation. Okay, substitute into this equation, this function to get one equation. And differentiate this way, dy with respect to x is equal to 0, and substitute this value to get another equation. So you get two equations and two unknowns a, b, and using simultaneous equation solve for a and b. Okay, discuss number 4. Given 91, 5 stationary point. Okay, on the curve y equals ax squared plus bx minus 4. Okay, and find the values a and b. Okay, and let's say we substitute. No idea kan? Substitute ni. Substitute. Nak tak mana? No. Bukan. Jangan memalukan. Ni. Silap. X, Y. Substitute. Tak boleh. Kan. Tak nombor kan. Okay. X, Y. Substitute. Let's say substitute lah. Kita tak ada idea. Substitute je lah. Ini 5. This one is 91. Ini 91. Tulis dulu. Okay. Dan ini equals A squared plus B minus 4. And dapat, okay, A minus B minus 4. So, dapat A minus B is equal to 9. One equation. You know, this is two unknowns kan? You at least two equation lah to find the unknowns. So, okay, this is stationary point. Means, kalau stationary point, confirm. Okay, confirm involve dy dx is equal to 0. Ni, stationary point confirm. Differentiate is equal to 0. So what to differentiate? Confirm lah dia given ni. So kita differentiate lah. Differentiate dy dx to ax plus b. Okay, to a plus b. So this one implies lah is equal to 0, right? Tak ya ni. So ini, this one is equal to 0 plus b is equal to 0. Why? Because this is stationary point ni. Dy dx is equal to 0. Then this one b right? Negative 2ax, and then x is equal to ni. Okay, x is equal to -1. Substitute dan dapat -2a -1, dapat 2a. Okay, b is equal to a, dan masukkan substitute ini. So ni, so dapat a minus 2a is equal to 9. So therefore a is equal to -9, and find b. Substitute balik. B is equal to 2 -9 -18. Okay, so that was number 4. Okay, settle for number 4. Okay, but make sure use all the info lah. The idea is this point. This point, pegang point ni, guna for all. Okay, mention stationary point, find, ingat dy dx is equal to 0, differentiate dia. Okay. pattern. Boleh?
Number 5, use the second derivative test to find coordinates that local extremum of this curve. Local means relative. Okay, extremum. Okay, to show that there is maybe maximum or minimum. Okay, so first thing, find differentiate function with respect to x. Find f or f prime of x. Find f prime of x and is equal to 0 to find x. And then to test the value of x, okay, the point, whether positive, maximum or minimum, then using the second derivative. Using the second derivative and check. Okay, and this one, okay, this one, x more than 0, this point is minimum. When double prime is less than 0, that point is actually maximum. Okay, discuss number 5.
Use the second derivative. Seronok sebab saya suka. Because of senang. Okay. Normally for polynomial, simple sikit kan. Use the second derivative to find the local extremum means that relative extreme may be maximum or minimum of the curve f(x), okay, x cube minus 6x square plus 9x minus 3. So first thing, differentiate f prime x, okay, 3x square minus 12x plus 9. Okay, so extremum atau whatever it is, terus f prime x is equal to 0. Nak find local extremum. Ikutlah kan, maximum or minimum. Okay, jadi this one, okay, 3x square minus 12x plus 9 is equal to 0. Okay, because it is equation, terus simplify, x plus 3 is equal to 0. Factorize. Okay, x minus 3, x minus 1. Okay, and then x is equal to 3 or x is equal to 1. Okay, two values for x and check lah. Okay, check when okay, the second derivative. Okay, so get one number and find the second derivative. Second derivative, nak check whether this one is maximum or minimum. Find the second derivative. Okay, from this one ni, this one, find the second derivative. The second derivative is, okay, 6x minus 12. The second derivative. And substitute. Okay, when x is equal to 3, when x is equal to 1. Okay, ni baru a value nak point and f prime of 3 minus 12 is equal to 18, 6 side. This one, okay, f double prime of 1, 6, 1 minus 12 is equal to negative 6. So label, this is more than 0. This is less than 0. When more than 0, ni more than 0, ni more than 0, less than 0. If more than 0, consider minimum. Okay, less than 0, maximum, the opposite. Minimum, maximum. Okay, so find the partner lah. Okay, f, okay, f of 3, substitute partner dia, 3 cube minus 6 square plus 3 minus 3. Cari. Ni 27 minus 954 plus 27 minus 3. 27 plus 54 minus mati 3, right? And this one 1 minus 6 plus 9 minus 3. Okay, This one is mati 1. Kan? Okay, double check double check. Okay. Okay, then okay, point. So point 3, -3. This one is X. This one is Y. Ni. Okay. And then 1, 1. Okay. This one X, Y. Ni. So conclusion is a local lah. Local minimum is a local maximum. Satu Okay, settle for number 5.